4.9 on to derivatives of exponential functions. Alright, so example 1, we want to sketch a graph of y equals e to the x. So it looks something like this. And of course we know that this point is 0, 1, because e to the 0 is going to be 1. Actually, anything to the 0 power is 1. Alright, and if we were going to sketch a derivative of that, we kind of already saw this in the beginning of the year, but if you sketch the derivative and kind of plan out the tangent lines, it looks the same. Alright, so you can see that on your calculator a little more exact. If you type in y1 of x, you type in e to the x, and in y2, you can type d for your derivative d, alright, of y1 of x. So that gives us the derivative of the first function. Make sure you use the right format here. This gives us the derivative with respect to x. That's what it tells us, to take the derivative with respect to x. So go ahead and check that out on your calculator. If you need to, you can make one of these bold because they will be right on top of another if you do it correctly. Now if we look at it analytically here, we see that the derivative of, okay, come on, here we go. Alright, derivative of e to the x is just e to the x. Alright, so for any function, though, if we have e to something other than x, we have to remember, using the chain rule here, to multiply by the derivative of the inside function. Alright, so we have an example to practice this. So dy dx, take the derivative of y, equals e to that x plus x squared times the derivative of our inside function, which would be 1 plus 2x. And that's it. If you want, you could distribute it out, but you don't have to. Alright, that's all we have to do. E to whatever it is times the derivative of that inside part. Okay, so example 3 is something that you can do on your calculator. And I want you to type what you notice into your whisk. Alright, so this way I know that you actually did it. So graph f of x equals 2 to the x and the derivative, and tell me what you notice. Are they the same, just like e to the x? Is one higher, one lower, one steeper, one narrower? Okay, and do the same for 5 to the x and the derivative of that. Okay, but for now we're going to look at the derivative of any exponential function, not just with a base of e. Okay, so when we're doing this, we have to take the derivative, alright, you just rewrite your exponential function times ln of your base. Okay, if we have anything other than x in the exponent, we have to do our exponential function times the ln of the base times the derivative of the exponent. Alright, so we're going to try this example with that. We have a function, we're looking for tangent line having a slope of 2, so we know we have to take a derivative. Alright, so dy dx, or y prime if you want to write y prime, equals, we have to take the derivative of 2t. Okay, in order to do that, we would have to just rewrite our exponential function times the derivative of the exponent, actually times ln of 2, don't want to forget that part, right, the ln of our base, times the derivative of this, oh, well, actually, I made that an x instead of a t. Alright, just ignore that part for a second, let me erase it, and let's start over. I used the wrong variables, I wouldn't want to mess you up. Alright, let's try that again. So, dy dt this time. There is no x in my function. Dy dt equals the exponential function times the ln of the base times the derivative of the exponent, which in this case would just be dt, or 1, and then the derivative of any constant is 0. So we want to know, where does that have a slope of 2? So we'd have to solve this. And hopefully you remember a little bit from pre-calc. To solve an exponential function, you have to get the exponential part by itself. So we're going to divide both sides by ln of 2. So we get 2 to the t equals 2 over ln of 2. And to get that out of the exponent, we can either take the log or the ln of both sides. Ln is a little bit shorter to write, so that's why I'm going to choose that. So take the ln of both sides. Okay, and if you remember correctly, all right, if this is an exponent, we can move it to the front. So we get t times ln of 2 equals ln, and we're not doing anything with this side, ln of 2 over ln of 2. Okay, and then the last step is just divide by ln of 2. So we have t equals, and this is going to look nice, a beautiful function here, ln of 2 over ln of 2 divided by ln of 2. Alright, if you wanted, you could get a decimal for that if you wanted an approximation of the point. But we were asking at what point? So we have to write that as a point. Alright, and we could rewrite this in a couple different ways. You're going to notice that with exponential functions, that you could write it in lots of different ways. If you remember your rules of logs, you could rewrite this using subtraction. Okay, when you divide logs, you can subtract them. And if you really wanted to rewrite it even more, ln of 2 over ln of 2, that's 1 minus ln of 2 over ln of 2. Alright, so there's a lot of things that we could do with this, but I'm just going to choose to leave it that way. So to get our point, ln of 2 over ln of 2 over ln of 2, and this is going to look terrible, but that's okay. Now we just plug it back into our function 2 to that power, which is ln of 2 over ln of 2 all over ln of 2 minus 3, and that is our exact point. Okay, not too bad, not too bad. Example 5, some of these will go very quickly. Some of them will take a lot of time. Alright, so let's just jump in and get started. Remember, d dx, that means to take the derivative of. Alright, so evaluate the following. We have an exponential function here. 7 to the, and I'm just going to rewrite the power in the top. Negative 3x to the negative 1. Okay, because I'm going to see that I'm going to have to use the power rule, and it helps to just rewrite it. Alright, so if I take the derivative of that, okay, and if I write it to tell you what I'm doing, take the derivative of this. First, we just write our exponential function. And then we multiply by the ln of the base. And then times the derivative of the exponent. Alright, which would be 3x to the negative 2. And I could rewrite this if I wanted. I could multiply 3 up on the top, 7 to the negative 3 over x times ln of 7. And I could put the x squared in the denominator. Alright. Actually, I could move this. This has a negative exponent, so if I wanted to do it one other form, one other equivalent form, would be 3 ln of 7 over x squared times 7 to the 3 over x power. Okay, because that was negative, I could just move it down. So those are all equivalent. Alright, let's try another one. E to the ln of x, if I'm going to just take the derivative of e to the ln of x. Alright, so we rewrite that times the ln of the base, which is a good habit to do that, times the derivative of ln of x, which is 1 over x. Alright, so looks like we could maybe rewrite some of these. Do you remember from pre-calc ln of e? That is just 1. Alright, how about e to the ln of x? Do you remember that from pre-calc? You can rewrite that if you had me using the ear rule, okay? It's like the reverse of that. Or e to, and remember ln is base e. So if we have the same bases, they kind of cancel each other out, and we could just write x times 1 over x, which is just 1. Alright, so now, if you take a look, we could have simplified this right from the beginning. E to the ln of x. If you know your exponential and logarithmic functions, you could just have rewritten that as x. And then the derivative of x is just 1, so we could have saved all of that time. Alright, letter C. This one is probably going to take up a little bit of space, but that's not too bad. Alright, so we have chain rule here, 2 times that inside part to the first power times the derivative of the inside part, which would be e to the negative t times the ln of e, which is just 1, okay, times negative 1, and actually, I'll just write that in the front, times negative 1, alright, or plus e to the t times ln of e times 1. Alright, so technically you could stop right there. Alright, but you could also keep going. We could rewrite this a whole bunch of ways. Alright, so I'm going to just switch these, because maybe you will see something, maybe you won't. Alright, e to the negative t. Why not? I'm going to switch those two. Alright, so hopefully I can. Okay, e to the t. I just like the positive ones in the front. So let me write that. E to the negative t times e to the t minus e to the negative t. Maybe you're starting to notice something. What do we call those things that are exactly the same except for the sign? Okay, they're conjugates. So that is the difference of two perfect squares. If we FOIL that out, you're going to get 2 e to the t squared, alright? Or I could just write times 2t. Remember, when you have an exponent to another exponent, you can multiply them. Minus e to the negative t, quantity squared, or just rewrite it as e to the negative 2t. Alright, so we're kind of condensing this a little bit. We could keep going if we want. Why not? You have plenty of time, I'm sure. This is a good skill to practice. Let's factor out least powers. Alright, so e to what, or e to the 2t times what would give us this? That would be e to the 4t, right, minus 1. And then if we really wanted, we could rewrite this as 2 times e to the 4t all minus 1 over e to the 2t. Okay? It might be better to write it in this kind of form, because if we want to find zeros or undefined values, it's easier to look at this, a fraction, rather than all of this jumbled up here. And of course, if I put a multiple choice question, it would be good to be able to change it around, rearrange it to see if it matches anything. Alright, I don't know if I have enough room for letter D. Maybe we'll do that one in class, okay, because I just don't have enough rooms right here. But I would like to do letter E. If you want to try D, go for it. Alright, there, notice we have, not only do we have the product rule, but we're also going to have the chain rule with 1, 2, oh, there's a squared there, 3, 4 functions. So there's going to be 4 pieces to that derivative right there. Alright, so if you want to do that in class, we can do that. Alright, letter E. E cubed. Is this an exponential function? It's not. It's just e cubed times x. So the derivative of that is just e cubed. Alright, and that is a great one to end on. So we're happy. Try it if you want. You could also probably finish any of the problems on the front page. So pick a couple, spend some time doing those, and don't forget to write your whisk. Okay, and have a great day.